Morning, everybody. Today we are going to be starting a new chapter, starting chapter 8. And in this chapter, all we're going to be doing is we're going to be working with exponents. So exponents, if you remember, are these little numbers up above our other numbers. Here we have 7 to the power of 3 times 7 to the power of 5. Now how we're going to solve this when it's a multiplication problem is we're going to see how many 7s we have. So in 7 to the power of 3, we have 3 7s. So we have 1 7, 2 7s, and 3 7s, times 7 to the power of 5. Well, if this was 3 7s, then here we will have 5 7s. So 7, 1, 2, 3, 4, 5 times. Now all we need to do to solve this is count up how many 7s we have. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 7 to the power of 8. Now all we're doing is simplifying these. You could solve this if you wanted to by putting it in your calculator, but we're just going to leave it like this for now. Here we have 3 numbers. We have 9. We have 9 to the power of 8. And we have 9 squared. So we're going to create our little table here. Here we only have 1 9, so we can just write it as 1 9. Now if we only have 1 9, we don't need to put that 1 on there because we already know how many that is. Here we have 9 8 times, so we can write out 8 9s. 1, 2, 3, 4, 5, 6, 7, and 8. Here we only have 9 2 times. So if we count these up, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 9 to the 11th power. Now our next problem, we have some parentheses. Don't let this confuse you. We're just looking for what's inside the parentheses. So we have -5. And we only have that 1 time. And then the other parentheses, we also have -5. But this is to the power of 6. So we're looking to see how many -5s we have. Here we only have -5 once. Here though we have -5 6 times. So 1, 2, 3, 4, 5, and 6. So what we have is 1, 2, 3, 4, 5, 6, 7 -5s. So we're going to keep our parentheses, -5 to the 7th power. The last problem on this slide, we have x to the 4th times x to the 3rd. So same thing, now that even if we have variables, we're going to draw our little table here, and we're going to count up how many x's we have. Here we have 4, so x, 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 and x. Here we have 3, 1, 2, 3. So how many x's do we have? 1, 2, 3, 4, 5, 6, 7. We have x to the 7th. So some of you may have noticed all we're doing really here is adding up our exponents, which is true. That is what we're doing. You can do that. But writing these out like this will help us later on. Here our next problem. Now we have inside our parentheses 2 to the power of 5. This is saying that we have 2 to the power of 5 3 times. So we are going to write out our 2 to the power of 5, third power, which means we have 2 to the power of 5 times 2 to the power of 5 times 2 to the power of 5. Now, what we need to do is we need to figure out how many 2's we have. So here we have 5 of them. So 2 times 2 times 2, and another 2, and one more 2. So 1, 2, 3, 4, 5. Here we have 5 more, 2, 2, 2, 2, and 2. And the last one we have 2, 2, 2, 2, and 2. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 2's. So we have 2 to the power of 15. Here on this problem we have brackets and parentheses, but don't let that confuse you. All we're doing here is writing out what we have in our brackets to the power that we have out here. So what we have is negative 6 squared, so we're going to write that, negative 6 squared. But we have 5 negative 6 squareds, so we can write negative 6 squared times negative 6 squared times negative 6 squared times negative 6 squared, and finally one more negative 6 squared. We have 1, 2, 3, 4, 5. So it says to the power of 5, so we got those right. Now we are going to create our little table here. And we're going to count up how many negative 6's we have. So with this squared here, it looks like we have 2 negative 6's. Here we also have 2 negative 6's. 2 more. 2 more. And 2 more. So now all I got to do is count up how many negative 6's we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 negative 6's, so we can write negative 6 to the 10th power. Now you might have noticed that all we're doing here is multiplying our exponents together and we get our answer. This is true, you can do that, but it's going to help you later if you write out all of our problems or all of our terms. Down here we have x squared 4 times, so we have x squared times x squared times x squared, and one more x squared. 1, 2, 3, 4 times. So if we create our table, we're going to see how many x's we have. We have 2 x's here, 1, 2. 2 x's here, 1, 2. 2 x's here, and 2 x's here. 1, 2, 3, 4, 5, 6, 7, 8. We have x to the power of 8. Now on this problem, we have a lot of things in our parentheses. So what we have is 9 and x, y, but we have that twice. So 9xy. Now what we're going to just do is we're going to count up how many terms we have of each number. So in this one we have 1 9, we have 1x, and we have 1y. Here on this side again we have 1 9 times 1x times 1y. So how many 9's do we have? We have 1, 2. 9 squared. How many x's do we have? 2. X squared. And how many y's do we have? Y squared. Now this is an okay answer. We can write it like this, but the better way to write this then is we can figure out what 9 squared is, which 9 times 9 is 81. So we can write 81, x squared, and y squared. So this here is our best answer. And just a side note, when you're writing variables, always write them in alphabetical order. So x comes before y. Now in this problem here, we have 3 7ABs. We have 7AB times 7AB times 7AB. So we have 3 of those. Now we need to figure out how many of each term we have. So we have 1 7 here times 1A times 1B. Then we have 1 7 times 1A times 1B. And we have 1 7 times 1A times 1B. So how many 7s do we have? 1, 2, 3. So we have 7 to the power of 3, or 7 thirds, or 7 to the power of 3, yep. A, 1, 2, 3, 3 A's. And how many B's? 1, 2, 3, 3 B's. Now you can leave it like this, or you can figure out what 7 to the power of 3 is by putting it in your calculator. I'm not going to do that right now. We can just leave it like this. A better answer would be to find out what 7 to the power of 3 is. Then we would have that times A to the third and B to the power of 3. Now here we have 2 that look kind of similar, but they are different. Here what we have is 2 of the negative 4z's in our parentheses. So we have a negative 4z times a negative 4z. We have 2 of those. So what we have here is 1 negative 4 and 1 z. Here we have 1 negative 4 and 1 z. So how many we have are 2 negative 4's, so negative 4 squared, and 2 z's, so z squared. Now we can make this into a better answer. Negative 4 squared would give us negative 4 times negative 4. And 2 negatives make a positive, so we have a positive 16 z squared. So positive 16 z squared will be our answer for this. Now this one over here, we have 2 4z's. So we have 4z times 4z. Now what we also have is this negative outside our parentheses. So what that's saying is really times negative 1. So we'll deal with this later, but right now we need to figure out how many 4's and how many z's we have. So on this one we have 1 4 times 1 z. Here we have 1 4 times 1 z. So we have 2 4's, so 4 squared, times z, 2 z's, so z squared. And we also have this times negative 1. So what we have here is 4 squared, so 16, and z squared, so we can write z squared. But we also have a times negative 1, so anything times negative 1 is just going to be the negative version of that number. So negative 16z squared. So this answer is different than this answer over here. Now this problem here, we're figuring out how many r's and how many other terms we have. So all we need to do for this one is create our table here. We have 1 6 and 1 r here. Here we have 1 8, but now we have 2 r's. So what we have is 6 times 8. 6 times 8 is 48. And how many r's do we have? 1, 2, 3. So r to the third. Or not r to the third, sorry, r cubed. R to the power of 3. Next one, we're trying to figure out how many terms again we have. So what we do have is 2 of the 2x to the third power. So we can write that out twice. We have 2x cubed times 2x cubed, and we have times x to the fourth, but we'll deal with that later, well before or after we get done with our 2x cubes. Well, we only have 1, 2 here. We have 3 x's. 1, 2, 3. Again, we only have 1, 2, but we have 3 x's. And on this one, we have just 4 x's. So x to the fourth gives us 4 x's. So what we need to do is count this up. We have 2 2's. 2 times 2 is 4. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 x's. So we have 4x to the 10th power. Now, here looks a little bit different than ones we've done in the past. But we still have parentheses, so we're still writing it out how many times that we have up here. So we have 9m cubed n. So we'll write that 4 times. So 9m cubed n times 9m cubed n times 9m cubed n, and one more 9m cubed n. So what we're going to do is count out how many of these we have. So if we make our table here, we have 1 9 here. We now have 3 m's. And we only have 1 n. In the middle one, we have 1 9, 3 m's, and 1 n. This one we have 1 9, 3 m's, and 1 n. And our last one, just like every other one, we have 1 9, 3 m's, and 1 n. So what we got to do is count up these terms. So first we'll start with the 9s. We have 1, 2, 3, 4 9s. So we have 9 to the 4th. And now we're going on to our m's. We're going to go in alphabetical order, so go to our m's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have m to the power of 12. And last but not least, we have our n's, 1, 2, 3, 4. N to the 4th. So our answer here is 9 to the 4th, m to the 12th, and n to the 4th. Alright, on our next problem, we need to figure out how many numbers in our parentheses we have. So it looks like we have 3. 3 8x squared y to the 5th. So we're going to write that out 3 times. 8x squared y to the 5th times 8x squared y to the 5th times 8x squared y to the 5th. So we're going to make our table and count out our terms. Here we have 1 8. We have 2 x's. And we have 5 y's. 1, 2, 3, 4, 5. Middle here we have 1 8. 2 x's. And again 5 y's. And our last one, we have 1 8, 2 x's, and 5 y's. So now all we gotta do is count them out. We have 1, 2, 3 8s. So 8 to the 3rd, or 8 to the power of 3. Sorry, I keep saying that. We have 1, 2, 3, 4, 5, 6 x's. So x to the power of 6. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 y's. Y to the 15th power. We have 8 to the 3rd power, x to the 6th power, and y to the 15th power. Last but not least, we are going to find the missing exponents. So how we're going to do that is we're going to figure out how many of each that we have. So we can start by making our table here. X to the 4th, we know we have 4 x's. We don't know how many x's we have here, but we do know that we have 5 x's on our equal sign, or behind our equal sign. So what we need to do is figure out how many more we have once we subtract the 5 from the 4. So we know we can get rid of 1, we can get rid of 2, we can get rid of 3, and we can get rid of 4, but that's all we can get rid of. Now what we have left is x, so we know that this is going to be 1x. So we can just write x or x to the power of 1. It doesn't matter. Here we need to figure out how many groups of 8 y's that we have to get y equals 16. So what we need to do is write out our parentheses. We know in one group of our parentheses we have 8 y's. So 1, 2, 3, 4, 5, 6, 7, 8, we know that's one group, so we can draw some big parentheses around those. Here we have 16 y's, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So what we know here is that we have one group of 8y's and two group of 8y's. Here we only have one group of 8y's, so we know that we need one more group of 8y's. So if this is 1, the next number here would have to be 2. So the number that goes where our question mark is would be 2, because we need two groups of 8y's. Last problem, we know that we have 3 2's. We don't know how many z's we have, but over here we know that we have 15 z's. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So we're looking for how many groups of z's we need over here. So we need to find our groups. We know we have 3 groups, so what times 3 would give us 15? Well, if we do 15 times 3, or 5 times 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 5 times 3 would give us 15. So we know that we have 1, 2, 3, 1, 2, 3, 1 group, 2 groups, 3 groups, 4 groups, and 5 groups of 3 z's. We know here in the middle that this, instead of a question mark then, will be 5. So we have z to the 5th power equals 8z to the 15th. Now we need to make sure that our 2's line up. So 2 times 2 is 4, times 2 is 8. So we know that 8z to the 5th times 3 here would give us 8. Sorry, not 8z here. We would have 2z to the 5th to the 3rd power equals 8z to the 15th.